Okay, we're going to finish up the last bit of knowledge before we are ready for our mid-unit test. The back half of Unit 3.7, which is trig modeling, but we might need to use a calculator. Okay, trig modeling, but we might need to use a calculator. We'll see. First, electricity. Alternating current is the form in which electric power is delivered to businesses and residences. It's, right here at the wall. And it is the form of electricity energy consumers typically use when they plug in televisions, lights, or any electronic appliance into a wall socket. Current, I, in amperes, which is amps, flowing through an alternating current circuit at any time t in seconds is this equation. That was a lot of words. Here's what this says. Current over time in second. So it's amps and seconds. That's what we're dealing with. Amps and seconds. Okay? Okay. So we have this positive sine model. And the first thing we've been told to do is just identify some parts of its equation, finding amplitude, not to be confused with amperes. So anyway, we're going to find the amplitude, the period, and the phase shift. What is the amplitude of this equation? 220. Very easy. We just read it right out the equation. 220. The period length has to be calculated. It's 2 pi over b. Our b is 60 pi. The pi's cancel, and 2 over 60 will reduce to 1 over 30. So we have a period length of 1 over 30. And the phase shift. Remember how College Board is going to have us do it? They're not going to say direction. We know it's a phase shift, which would mean hold on, I can say this. We know it's a horizontal shift. Because it says minus 1 over 360, is that going to be left or right? It's going to be to the right, but because it's to the right, we're just going to say positive. So we're just going to say shift 1 over 360, and we are all to know that because it's a phase shift, it's horizontal, and because it's a positive number, it goes to the right. All right, so it says to graph 2 periods of this function. That's an issue for us. And the reason why is because the period length is 1 over 30, but we phase shifted to 1 over 360. Let me show you how I would have done that. You don't need to write this. Don't worry. I'm going to come back, and we're going to translate what I'm about to do on here onto that grid. Okay? Here's how I would have handled that. First, you need your period length and your phase shift to have a common denominator. We need that. What is the common denominator between 30 and 360? No, that's the common factor. What's the common denominator? 360. So the common denominator is 360. So what that means is, instead of saying the period is 1 over 30, we're going to say that the period is 12 over 360. And the reason why we want to do that is because we're going to start at 1 over 360, and then we're going to go 12 over 360 from there. And that'll make life really easy to graph. So we're going to do this. Picture not drawn to scale. What I'll do is I'll just say this first mark is 1 out of 360. And since the picture is not drawn to scale, what you're going to do is you're going to put this little lightning bolt symbol in between there. And that means that from here to here is negligible. We're not going to worry about its size or its scale. That's what that means in mathematics. It also means none of that stuff mattered. Okay? Okay. All of our waves are broken into 4 pieces, right? So I'll say my period length is going to end there. I just chose an arbitrary distance, and I put a mark there. But I know that it's 12 away from 1. Halfway in between them is, well, that's a distance of 12, so that's a distance of 6. And we know that we're going to have 2 marks in between them. I won't bother because those are going to be decimals over 360, or they're going to be numbers over 720. The point is, I would have done it like that. This, and then I would have gone, okay, and then another distance, and I would have added another 12 because it did say 2 periods. So that's how we're going to tackle that. Now, if you look at how many tick marks that takes, you see it's 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks. And if we come to this one, it has 1, 2, 3, 4, 5, 6, 7 at best. So here's what I'm going to do. I'm going to do this. And I'm going to let this first one be 1 over 360. And I'm going to cut all these in half. And I'll just use as many as I needed. Cool? Alrighty, so we know four marks to the right of this, 1, 2, 3, 4, is going to be the end of that period. That's going to be 13 over 360. So halfway between them would have been my 7 over 360. 4 marks to the right, that's my 25 over 360. Only 2 marks to the right would have been my 19 over 360. And see, if you do it this way, you could even keep going. So yes, I'm aware that the scale is off, but this little lightning bolt thing says, don't worry about it. We won't be concerned about anything to the left of 1 over 360. Okay? Now, this is a positive sine wave. Where do positive sine waves begin? The midline. The midline. Positive sine waves begin at the midline and go up. This thing has no vertical shifting. So I'm going to start here. And then after my first tick mark, I'll be at my maximum of 220. Luckily, the y-axis counts by 20s. So 220 is right there. And then back to your midline. 220 is, negative 220 is down there. There's 1 cycle. And there's 2 cycles. There. Alternating current. Oh, I missed this dot, didn't I? The last part says, where are the x-intercepts? Well, they start at 1 over 360, right? But then how often do we hit the x-axis? Every 6 over 360. Now you could reduce that to 1 over 60 if you wanted to, but I find that harder to graph. So I'm just going to do this. And I'm not doing minus because we're saying nothing exists to the left. Where n is an integer. Okay? There it is. And that hits every one of those x-intercepts. But in this question, what are those x-intercepts? What do they represent? Yeah? When current is 0, yeah. So this is where current is 0 amps. That's what that is. That's where your current is currently 0 amps. What a weird thing to say. The current is currently. There you go. Not bad, right? Yeah.
If the current's 0, then everything else is 0. Oh, wait, no. Everything but the resistance is 0.
Everything else but the resistance is 0. But that's at that instant in time, though. Because, you know, it alternates so fast, you know. Did you know, a little bit of history lesson, that in case you're not in physics, there's 2 kinds of electricity. There's alternating current, which is what we get from our wall sockets, and there's direct current. Yes? Did you know that early on in American history, there was a debate about which one we should have in our power lines, and we were almost powered by direct current? We almost did that.
That's when the first electric charge happened. Alternating currents were dangerous.
No, I think I thought that direct current was more dangerous. You know, I don't know. We'd have to talk about dangerous. We'll do that when we get finished with the lesson. What does it mean to be dangerous? I don't know. Alrighty. Cheryl opened a bakery and found that her monthly profit followed an up and down pattern during the first year. She discovered that her profit could be modeled by this equation, where P, profit, is measured in hundreds of dollars and T was measured in months after January 1. Okay, let's talk about that. Because this represents x equals 0. And that's kind of tricky. And I had to literally count this on my fingers in last class period that I taught this. So what that means is when x is 1, February 1, so February 1st, March 1st, April 1st, May 1st, basically the x value is 1 less than the month value. So December 1st would be x equals 11. So what is x equals 12? It's January 1st of the following year. Cool with that? All right. It says, when did the bakery first begin to make money? And explain how you know. And it says use a graphing utility, so we're going to go directly to graphing calculator. Now, when you go to graph any trigonometry, please make sure your calculator is in radian mode. Yes? Because it says T is the number of months after January 1st. So if x is 1, you are a month after January 1st, which is February 1st. So if you say x equals 12, you're talking about the following January 1st. Okay. Anyway, make sure you're in radian mode. Anytime you have to graph any trig, go to y equals 2x minus 7 sine alpha y equals stack fraction pi over 3. Remember, pi is right here. X. And we're going to think about our window before we hit graph. All right? In the window, this question's talking about the first year. So January 1st to January 1st is 1 year. That is 12 months. Yes? Okay. Might as well count by ones. Y minimum is 0, the way my screen is set up right now. But it says, when did the bakery first begin money? When you first open a business, you're actually in the negative. It takes a little while before you're actually profitable. So that means negative y values make sense. We're in debt. And our money is counting by 100s. So, I don't know. We could just guess. How much money do you think? This is showing an amplitude of 7, so like 700 maximum if we hadn't seen this. 700 minimum, negative 700. So you want to say like negative 1,000? Which would be negative 10. That's negative $1,000. You know, because we're counting by 100s. And what do you think our maximum could be? We could do the same thing and see what happens. Okay, let's see what happens. All right, clearly my y values didn't go up high enough. Now, just so you know, if you don't want to wait for it to finish graphing, try to shut the calculator off, it'll stop. We need more y values. Let's go up to maybe 20. Let's try 20. I like 20. I'm afraid 15 won't be big enough. Let's try 20. Oh, I forgot to adjust my scale. Whatever. Is 20 going to be high enough? Oh, we still fall off? All right, let's take it to 40 then. 40 seems good. And I will adjust my scale to say 5. Because that's a span of 50. All right, that should fit. That should be good. What a neat graph. Okay, cool. It's just showing our profits going up and down throughout the year. Okay. It says, when did the bakery first begin making money? Where do you think that occurs? Not what the answer is, but on a graph. Where would that occur? At the x-axis, the x-intercept. So we need to figure out where that is. Y equals 0 graph. It's going to put a secondary line on there for me now. And now I can do second trace intersect. Been a while since we've had to do this, but time to dust off those skills. Second trace intersect is 5. Boink. Hit enter, and then scroll to where the answer roundabouts is. It's about right there. And hit enter one more time at 2.311. We first began making money at x equals 2.311. So let's talk about when that is. So we have February 1, March 1, April 1. Okay, clearly it's between 2 and 3. So it happened between March 1st and April 1st. So this is during March of the first year. We don't need an actual date. During March. Explain how we know. And this is because P of T turned positive. I mean, if you really wanted to know. How many days does March have in it? 31? 0.311 times 31. Whoops. 0.311 times 31. Yeah. Happens halfway between March 9th and March 10th. So it's like halfway into March 10th. It's like noon on March 10th. Oh, that was a guess? Good job. But we don't need to know that. That's over and above, okay? Now, part B says, in what month did her shop make its greatest profit in that first year? So if we go back to our graph, I'm actually going to get rid of, actually, no, there's our graph. Clearly, our greatest profit happened right there. And we need to find that. That's a maximum. So second, trace, maximum is number 4. And it says left bound. All right. Scoo-dooby-doo. There's left of the answer. There's right of the answer. And the real answer is somewhere in between there. And we hit enter one more time. And it looks like we have a maximum at, and I'll do it in green since it's money. This is 10.764, comma 28.262. So it says in what month? Well, again, I have to count on my fingers because, yeah, but I'm just going to count on my fingers anyway. Ready? February, March, April, May, June, July, August, September, October, November. So it happened sometime in November. And then it says what the profit was. Remember, this is in hundreds. So it's 28.262 times $100. Well, did you read the question? It says that it's a bakery. So 2826.2. It's only $2,800 profit that month. Not a whole lot of money in this bakery. Anyway, someone in second period said she doesn't make bread like that. Get it? Because it's a bakery. It was Colin Carter. I liked the joke. I thought it was cute. Of course I did. And bloop. Here we go. I'm going to be honest with you. We've basically done everything we need to do for the lesson, but I am going to show you how to do sinusoidal regression with this question, and we won't even bother doing the last one. It's not really worth our time, okay? Hurricanes are categorized using this hurricane scale. The table below represents the number of major hurricanes in the Atlantic Basin that are rated as major storms of category 3, 4, or 5 for every decade from 1921 to 2020. Use a graphing utility to create a scatter plot. And these decades are our t values from t equals 1 to t equals 10. And through the magic of I did this in second period, stat edit, I already have my lists filled out. So I'll pause the video while you fill yours out. Okay, that should have been enough time for you to get them typed in. Now, I'm curious to know what this scatter plot looks like. Okay, so I'm going to go to y equals, it's cleared out. I'm going to turn on plot 1, and my window is going to go from 0 to, I'll take it from 0 to 11. That way all 1 through 10 are on there. And the biggest number is an 11. The smallest number is a 4. So let's go from 0 to 12. How's that sound? Okay. It's not terribly sinusoidal, is it? I feel like this dot, if this dot was higher, it would be better. But whatever. We're being asked to find a sinusoidal regression function that best models the data. We're going to do our best with this one, okay? I'm not going to lie. Sinusoidal regression on this calculator, it does some things I'm not really sure about, which you're about to see. So stat, calc, and if you scroll down really far, you'll see sinreg, this sine regression. And we're going to hit enter on that. Now here's what's up. When I checked on YouTube, it said, don't change any of these things. Leave iterations at 3. I don't know what that is. Obviously, X list and Y list should be L1, L2. We know that. And the video said, don't change the period length. Okay, I have no idea. So what I'm going to do is I'm going to store my equation because I want to graph it and see how it lines up with those dots. So vars, y vars, function, y1, calculate. There. So I've got a trig regression. Now I'm going to hit graph on this after I answer this phone call. Okay. I guess I'm going to write this down and then I'll graph it because I don't want to have to go through the whole calculate thing again. So I'm going to go ahead and write this down. Y equals 2.471 sine of, and what's interesting is that it's not factored. The argument, it's not factored. So it's going to be 0.956x minus 1.456 plus 6.655. And I'm curious to see what that graph looks like compared to the scatter plot that we just had. Graph. I mean, it could be worse. That's not that bad, right? So yeah, I don't know what iterations does, and I don't know what would happen if I restricted the period length. I have no idea. But we could see that it did relatively decent job, right? Okay. So it says, based on the model, what is the maximum and minimum number of storms? But remember, our model shows us a midline with an amplitude. So it's not what is the actual minimum and maximum, it's what does the model predict? Well, our maximum is going to be the amplitude above the midline, so 6.655 plus 2.471, and our minimum will be the midline minus the amplitude. See what we get. .126, so about 9 storms maximum, and 6.655 minus 2.471 is 4.184, or about 4 storms. Now, based on our model, in what decade will the next maximum number of storms occur? We have 2 ways that we could do this. We could either extend our graph, our x-axis, until we get another maximum, or we could see that the model's maximum occurs at that data point, and we could do 2 pi over b to figure out the period length. I mean, that's completely up to us how we want to do it. Since we're doing graphing calculator stuff, I want to just extend my x-axis and see where the next maximum occurs. That way we can practice doing second trace maximum stuff. Cool? Okay. From here to here, can we agree that this is roughly, I don't know, 6 or 7? Roughly 6 or 7? So if we go out another 10, we know we'll capture another one, right? So if I go from 0 to, I don't know, 20. Next maximum is right there. Right there is the next maximum. So we need to do second trace maximum to figure out where that maximum is. To the left, to the right, in the middle, at 16.318. So, over 6 decades, from 2011 to 2020. So where does that put us? Oops, I missed a 0. There we go, 2020. If I add, I have to go over 6 decades. So going to 2080 is not enough. I have to go past 6. So from 2081 to 2090, yeah, because 6 more decades would have put this number at 2080, right? So I had to go past that. There it is. Yes? Oh, where did I get 6 decades? Because this goes up to 10, and my next maximum happened at 16 and change. That's where the 6 came from. Yep. Alrighty. Now, the next part of this lesson, I'm going to be honest with you, we're not going to go through all of the trouble of it because I don't feel like typing all that in. So we're gonna plot it like it says to do, and we're just going to look at some of the questions and just talk about context, and then we'll call it a day on that stuff, okay? Or we don't really have to. Let's just talk about real-world scenarios. This is talking about your average temperature from month to month. And if we plot it, what we see is that we get a roughly sinusoidal behavior. My question for you is, why does a sinusoidal model make sense for average temperatures? What do you guys think?
What
But why, Isabella? Because of the seasons. And I would argue, if you even want to go that reason, or that route, why do we even have seasons? Because we have a roughly circular orbit. And moving around a circle is what creates sine waves. And the tilt of the Earth. But yeah, as I say, it's a bit of both. And later on in the questions, it just wants us to talk about what inflection points mean. But it really isn't even in the context of the question. As long as you understand that an inflection point is a place where the rate of change stops increasing and starts decreasing, or the rate of change stops decreasing and starts increasing, then you understand what it means to be an inflection point. And the maximums and minimums of the regression model are literally just the predicted average maximum and minimum temperatures. So there isn't a reason to do another one of them. And I hope that none of my nerds will be upset with me for not doing that whole question, because we just did. We just did. We got this.